Hello everyone, this is the first lesson recording for IM1, April 23rd, 2021. We started off by watching this funny video on Gangnam Style math. It's on transformation. So hopefully you get a chance to hear it, and hopefully whenever you watch or hear Gangnam Style, then you are going to be thinking about transformation. That includes reflection, translation, and baby rotation. And that's transformation style. I thought it was funny anyway. Okay, goal for the day. We're going to study how to define transformation rules that computers can use. So if you're thinking about graphic designers for all your video games or animations or anything like that, what do they do? There's a lot of transformation that is going on when we're talking about movement of shapes. And they certainly do not use petty paper, tracing paper, but they use algebraic notations to move things around. And we're going to be using that and learning about that. And we're also going to be talking about symmetry. And before we get started, let's summarize the three different transformations that we know about. What are they? The first one is translation, where a shape can be moved left to right or up and down. So it's another term for it is shift or move, such as the light blue triangle is moved to the dark blue triangle. How do I know that it was light blue triangle was the original? It's because that vertex has the notation of A, and that corresponding point right here has the notation of A prime. A prime tells me this is after the transformation, whichever one, whether it's translation, rotation, or reflection. So we know that this is the original, this is after the transformation. And in this case, the triangle was moved 2 units right and 2 units down. You just pick one point that are corresponding and decide how much it has moved. That's how you tell. The next transformation we talked about was reflection. And with reflection, you're always going to have a line of reflection. That line of reflection can be x-axis, that's a horizontal line, or y-axis, that could be a vertical line, or any horizontal or vertical line. And we know how to write those equations. Or it could be diagonal lines such as y is equal to x or y is equal to negative x or any other straight line. But again, line of reflection is going to be a straight line. It can be anywhere. An example is this light blue triangle turning into dark blue triangle. The line of reflection was a vertical line and it has the equation of x is equal to 4, where it is going through x is equal to 4, 0, and so on. The last transformation, of course, is rotation. That's the last one that we covered last lesson. And with that, you're always going to have center of rotation, and you're going to have to define the direction of rotation, clockwise or counterclockwise, at least unless you're doing 180-degree rotation, and also the amount. It can be any amount, but for now, let's focus on 90, 45, or 180 degrees or whatever else. And here is an example. The triangle on which one is the original, which is the new. The original is the blue one. How do I know? Because it has the notation A, B, and C, whereas this has notation A prime, B prime, and C prime. There's a little apostrophe on each one of them. That tells me that the after transformation is this orange triangle. And what happened with this one? It shifted, it rotated, it didn't shift, it rotated, it turned as if the anchoring point was at the origin. If you had the pencil right there, it turned about that point by 90 degrees because this is making a 90 degrees right angle symbol. And it was turning counterclockwise. All right, so I want you to tell me in private chat, what sort of transformation do you see? How can I tell which is the original, which is the after the transformation? Again, it's going to be by the notation. When you see the corresponding points, A to A prime, okay, A to A prime tells me this was the original A, and the new is A prime right there. So this is the original shape, and this is the new shape. Also look at the way the points correspond, match up. Okay, so C and C matches up, that's pretty obvious, but D matches up with D prime there. So D transformed to D prime. So you might be thinking, yeah, it looks like the shape just slid down. Is that what happened? Well, if it just slid down, or slid up actually, because this is the origin, if it just slid up, the bottom diamond should be a B prime, not D prime. So it's not a translation, okay? A, B, C, D is the original image, A prime, B prime, C prime, D prime is the reflected image. It's a reflection because D is at the bottom here and D is at the top of this. D prime is at the bottom, D is at the top of this diamond. Okay, so it has to be a reflection about the x-axis. And so we use the prime, that apostrophe looking thing on letter, to indicate transform the location. So they do match up. C and C prime, they match with each other. And we read A, the apostrophe B, apostrophe C, apostrophe D, apostrophe as A prime, B prime, C prime, and D prime. You should say it to yourself at the very least so that you do get used to the vocabulary here. All right, then I want you to tell me which one is the original. Is it the blue figure or the green figure? How can I tell? Well, look at the notation. Okay, I have S and S prime, R and R prime. Which is the one that we started off with? The one that we started off is the one without that prime notation. That prime tells me that is after the transformation. So the blue is my original and the green is after the transformation. So now, what is the transformation? Okay, so is it a translation? Is it a shift of the left shape to the right shape? No, because the orientation is different, right? As well as the letters do not match up. So what is it? Well, S is close to this line and S prime is also close. Okay, S was on the right hand side of this figure, but now it's on the left hand side. So hopefully you can tell that this is a reflection about, and with the reflection, you always need to define the line of reflection. And the line of reflection is the y-axis. It's the vertical line along the y-axis. All right, what about this? What do you notice as the transformation? Okay, so which is, first of all, which is the original? Is it the black triangle or the blue triangle? It's the black triangle because it's the one without the prime notation. So LMK, triangle LMK, and we have triangle L prime, M prime, and K prime. So L and L matches up, M and M matches up, and K prime matches up, right? So they're the corresponding points. So what was the transformation? Well, which one was the original? Original is the black triangle. And describe the transformation fully. What was the transformation? It's as if that was anchored right here and the figures just turned. Okay, so that's the only way I can get this to match up like that. So if I even have a diagonal reflection line, the M should be over on this side and L should be over on this side, and that is not so. So it is rotation, and its rotation about around the origin. The center of rotation is at the origin, which is 0, 0, where the two axes intersect. And what was the degree amount? It was 90 degree will be somewhere here, 180 degree will be over here. And again, 180, it does not tell me, we do not need to define as clockwise or anti-clockwise the direction, because 180, whether you're going clockwise or anti-clockwise, makes no difference. It ends up in the same position, okay? And we can demonstrate that just precisely. So if you, this is the duplication of the same slide. So here, this is my original. And if I rotated this, if I rotate this like so, this is 90 degrees. 90 degrees would end up with a triangle looking like this. And if I rotated another 90 degrees until the axis, x and y axis match up again, it's going to be right there. So 100 after 180 degrees, this is going to be the original shape, and it matches with the transformed triangle right there. So we know that this is rotation around the origin of 180 degrees. Okay, so which one's the original? Is it the black triangle or the blue triangle? It's the black triangle because it doesn't have the prime notation. The blue one does, x prime, y prime, w prime. Okay, describe the transformation fully. Okay, is it reflection, rotation, or translation? Does it look like it flipped? Does it look like it turned? Or does it look like it just slid? Well, looking at the orientation, W is at the bottom, W is at the bottom here. Y is on the left and X is on the right. Y is on the left, X is on the right. So it tells me this is a translation. And more specifically, you pick any point here. You can pick the X prime and Y X. So you need to be thinking, okay, how did X become X prime? So you need to be thinking, okay, it went down by 1 unit and it also went 1, 2, 3, 4, 5 units to the left. So left 5 units, down 1 unit is the transformation. What about this? Okay, so again, this will be translation because the orientation is the same. And you can look at the C and C prime. How did C become C prime? It moved to the left by 2 and up by 1. So it's going to be translation left by 2 units, up by 1 unit. So you just pick 2 corresponding points and figure out what happened to the original to get to the final. All right, so now we're going to be working on transformation rules. So I want you to work on card number 1 to 5, please. Here you have a quick check-in as to how are you doing today. There are many different cat faces. Who do you identify? And you can tell me more about it. Next up, translation rule. Play with each button and see what happens to the image. So if I click on the first one, that's my red is my origin. It transforms to the blue over there. Okay? Or if I pick the next one, it moves to down here. Or if I pick third one, it will move to over here. And then fourth one, it will move to over there. Okay, so now let's look at the numbers. Okay, so if I was to pick 2 points, okay, if I pick this point and this point, they are the corresponding vertices. So I know that the red was the original, so that point became that point over here. So how did it change? It went down by 1, 2, 3, 4 units. So it went down. And remember when you're going down on the vertical axis, you're becoming more negative. It went down, so it's -4, and it went to the left by 1, 2, 3, 4, 5, 6. So going to the left by 6 means it's becoming more negative. So we say it's -6. And notice what happens here. So whatever the x value here, and I can even put the coordinate here. What is the coordinate of this point? It is 1 comma or -1 comma -1. And the new coordinate for this is -7 comma -5. And look what happened to the x coordinate. X went from -1 to -7. And that is subtracting by 6. Or you can think of it as it's moving to the left by 6. So you can think of the vertex, the coordinate, or you can think of the movement. And that's where I see x minus 6. And moving down, the y coordinate went from -1 to -5. It went down by 4 as well, or it got subtracted by 4. And that's the notation that you should be noticing. That's how we write our rules. And we'll continue on the next recording.